Hello everyone and welcome to another video for Elephant VFX Patreon feed. Today we want to talk about PDGs and TOPs. If you're not familiar with these two concepts in Houdini, PDG stands for Procedural Dependency Graph and TOPs stands for Task Operators. And that is this network that you have here called tasks. I don't remember talking about TOPs or PDGs on my channel yet. I think this is going to be the first time. So yeah, this video is going to be a basic introduction. Well, maybe not that basic, but an introduction anyway about how to use these two things together. So you might be asking yourself, why do I want to use task operators? And the thing is, task operators and procedural dependency graphs are basically pipeline tools that allow you to automate tasks. So you can actually use it for anything that you can imagine in Houdini. You can use it for procedural modeling, you can use it for lighting and rendering, you can use it for crowd simulations, for RBD simulations, for pyro simulations, whatever. I mean, anything that you can do in Houdini, you can benefit from using task operators. In my particular case, I have to say that I'm not that exposed to this workflow. What I mean by that is like, I never use it for making environments, for example, which is something that I maybe should be trying more in the future. So again, because you can use it for anything in Houdini, I don't have that much experience using TOPs and PDGs for many different tasks. What I usually, or I would say my most common workflow using PDGs and TOPs, generally speaking, is for creating wedging. And wedging of any kind, right? So for example, if I'm modeling an environment, let's say a natural environment, and I need to make rocks, procedural rocks, I would make maybe one setup that can give me very nice looking procedural rocks. And then by using TOPs, I'm going to automate the process of creating 100 different rocks that then I can scatter in my environment, right? So yeah, that's one type of wedging, right? Creating variations of one particular asset. Another type of wedging, and this is very common for lighters in visual effects, is to create a wedging of a particular lighting scenario. So you're doing a full CG shot and you might have whatever environment, everything full CG with a character and a spaceship. And you might think, I don't know if the lighting direction, the key light should be north or south or west or east or whatever. So you do wedging, right? You animate your dome light or your key light so you get frames with different lighting. That's also something that you can automate using TOPs and PDGs. And many other things, like you are doing a smoke simulation and you want to get one version with very high wind, another version with a wind that is a little bit calmer, and maybe another one without wind. Or one of those simulations should be influenced by regular gravity on Earth, but maybe you want to try something with value of 20 affecting gravity. All those things can be automated using this workflow. So I'm going to get into it because it's easier to see than explaining it, I think. So basically, I'm going to create a geometry here. I want to show you a couple of different examples today. I want to do one with where we create some kind of procedural asset, something very simple, but hopefully you get the idea. And then I want to do something with simulation because, yeah, this is basically what I use it for. I use it for, again, asset creation, simulation wedges, and a lot of lighting wedges as well. So we're going to do a little bit of that. This is what I would consider, or well, Houdini considers TOPS and PTGs as pipeline tools. I see them as pipeline tools, but also as an artistic tool that can empower artists to create content faster. Okay, so let's jump into it and let's create something procedural, something very simple. So what I'm going to do is I'm going to create a box, and let's pretend that this is a complex asset or whatever, and we want to create different variations of this box. So I'm going to use an RBD material fracture here, and you probably know this workflow if you usually work with RBD simulations. I'm not going to do a simulation, I'm just going to create a static asset here, but you will get the idea. And I'm going to do an RBD explode view so we can see all the different chunks here. Let's do something like 0.2. All right, and this is what we get. Okay, cool. So again, my goal here is to create multiple assets. I want to do some kind of operation to this asset, like damage this asset. Let's say this is a rock and we want to break it, or this is a hard surface modeling and we want to break the edges. So let's do that. Then I want to create multiple variations. Then on top of that, I want to create variations in different aspects, right? I want to create a variation of size. I want to create a variation of how many pieces I'm breaking. I want to create another variation of how much damage this asset might have, and whatever might come to your mind. We can create variations of anything. I mean, any parameter that you can think of in Houdini, you can use it in TOPS to create wedging, to create variations. Then I want to cache as BGeo all the geometry. But I also want to publish it as USD, for example, because my pipeline is full USD. So I want to work in a full USD pipeline. So I want to cache everything as USD. And then I want to render each of those assets individually with a lighting setup that I'm going to create in LOPS. Again, everything would be full USD. And once I have that, I want TOPS and Houdini to create a contact sheet. So all those assets are presented to me with all the different variations that I want to create automatically. So the next day, let's say I spend like a day working on this, I click a button, and it takes, let's say, 5 hours to create all those variations and to render all of those individual assets. Then I want Houdini to put a contact sheet for me. So next day in the morning, I have the results. I see 50 different variations, and I can say, oh, I actually like 2, 10, and 24. So let me grab those and put them in the project. Or if I'm creating something procedural like rocks, I might need all of them, like all the 50 or 100 or 1,000 different variations that are going to be created automatically overnight. That is the plan. Okay, so we're going to make a skeleton setup, like a recipe, something that we can reuse later. We're going to start extremely basic, and then we're going to build over that. And then we're going to jump into the simulation, and maybe we can introduce a few more things here and there. Okay, so going back to my RBD material fracture, this one by default has 2 layers of fracturing, which I don't want. I just want one, so I'm going to get rid of one. Okay, so we have this basically, and this is fracturing based on these points. I'm going to set this one to 0 because I want to control that in a different way. So I'm going to create a scatter node. I'm going to pipe this one here, and I'm going to scatter a few points, and that's what I get. 1,000, which is probably too much. So I'm going to set this one to something like 5 points. So now we have 5 points, and our fractures are going to be based on this. We can play with the relaxed iterations if we want to. Cool. So now in our RBD material fracture, I'm going to enable input points, and I'm going to input these points here. So now the fracturing is given or is controlled with these points, right? So if I set that one to 15, I would get 15 different fractures. Okay. So to keep things simple, I'm going to start with 5. So I get 5 different fractures here. Okay, great. The next thing that I want to do is I want to damage this asset a little bit. So I'm going to use the labs edge damage, which works very well. Again, if you're familiar with RBDs, this will have three outputs here. One is the geometry, the other one is the constraint geometry, and the third one is the proxy, which in this case we haven't created any proxy, so it's the same input as the geometry. We only need the geometry for this exercise. So I'm gonna get geometry, enable this edge damage, which is doing a little bit of work here, and this is what we get. All right, cool, fine. So by default, this one uses the VDB method, and I actually want to use Boolean. It creates dirty geometry, but Houdini can handle this very well, so no problem. And we get something like this, right? Which, you know, looks cool. I mean, again, let's pretend this is a complex asset and not just a cube that we split into parts using the RBD material fracture, and then we damage the edges. Let's pretend it's something a little bit more complicated. And of course, here we can control the amount, the resolution, the noise that we're using for creating that and whatnot. So if we use a value of 6 in the amount, of course, we will get more damaging, but let's just set it to 3 for now. Okay, cool. Now, let me add a match size and justify this one to the minimum in the y-axis. So it's sitting in the origin of the wall. Okay. In between, let me just create a color here that I'm gonna set to black. And now I'm gonna create another color that I'm gonna set to white. Because basically I just wanna create a mask for the damage areas. And as you can see, the edge damage node here, it's exporting an attribute point called mask. So if in my color, I set this one to points, and I said at mask equals 1, meaning where the mask value is 1, then I get that mask in my color that later I can use for shading in Solaris. All right, cool. So this is our basic setup. Again, it can be as complex as you want. And later on, we're going to take a look at the simulation, which is way more complex than this. But the principles are exactly the same. So this should give us what we need. Okay. Now I'm going to add a file cache. And I'm going to call this one something like box. And I don't care about simulation or animation here. This would be a static asset. So let me disable the simulation, set this one to single frame. I don't want this to be time dependent. And I'm going to create a folder for this, which is going to be in my variable job, a geometry, okay? Here, I want to create a new folder for us. I'm going to call this one Live English, and then BGeo. This is where I'm going to save my BGeo geometry. I'm going to save different type of geometry later because I want to also publish these assets as USD. So I'm going to click on Save to Disk, and this is saved to disk now. So all of this has been cached. All right, cool. I'm going to add a null that I'm going to call out. And this is what I'm going to use for rendering in Solaris. So let me jump to Solaris Lookup and let me set up something quickly here. And again, everything that I'm doing now is the skeleton. It's basically the basics of what I want to reuse later in TOPS, in task operators. So I'm gonna start by sub-importing my box, which is this thing. And I'm gonna create, or I'm gonna rename this. Okay, cool. Now I could create a camera and use this camera for rendering, right? But there is one limitation in Tops. Well, it is not a limitation, but basically I want to do certain operations that require my camera to live in subs instead of lobs. So instead of creating my camera here, I'm just going to create my camera here in subs. So I'm going to create a camera, and now I can look through this camera, and let me put this one somewhere here. Okay, so this will be my render camera. So let me jump back to stage, and now we can do a scene import camera, and now I can look through my camera here in subs. Okay, cool. Let me add a merge here, and let me add a grid. And this grid, I want it to be big enough so it covers, you know, the whole camera view. Okay, cool. What else do I need here in order to render this? Well, of course, we need some materials, right? So I'm gonna create a material library. Go inside and let me create a Karma material builder that I'm gonna call box material. Okay. Right, cool. Let me configure that a little bit later. I need another Karma material builder. This will be just a gray shader for my grid. And let me do some kind of white-ish color, and maybe increase that to 0.4. All right, or 0.5. There you go. Cool. Next, let me assign those materials. So the box should use the box material, and the grid should use the grid material, or the gray material. Okay, what else do we need? Of course, we need a light. So let me create a Karma physical light. And of course, we need Karma render settings. I'm gonna set up my camera to camera 1, and I want to disable depth of field and motion blur. Okay, so if we render this, I'm rendering with XPU. I'm gonna set the render settings also to XPU. By the way, I'm going to disable or decrease the path trace samples quite a lot. This is just for render testing. So I'm gonna just set like a 1 sample, which gives me something that is very noisy, but who cares, right? This is just a quick render test. Okay, maybe 3 samples. All right, and my Karma physical light, I'm going to increase the exposure a little bit. Let me double check my correction toolbar and make sure that I'm using ACES. That's all good. Maybe I want to rotate this a little bit. Okay, something like that. That's so much. 35. All right, this is my setup. And this is what I'm going to use to render my contact sheets automatically overnight with all the variations that are not even created yet. Okay, we can reuse all these things. But let's work a little bit this material. So basically what I want to do is I want to mix 2 different shaders based on the mask that we created for the damaged edges. All right, so if we go here, this close, we can see the damage on the edges, and we want to use a couple of different materials for that. So let me use material X mix. Gonna connect that one to the surface, and what I want to do is I want to connect this one to the foreground. I want to connect that one to the background, and now I need the mask that we created in subs. So I'm going to create a material X geometry color. Okay, this mask lives already in the CD attribute, So we can keep it there, but this is a vector. So let me add a material separate vector 3, connect the input, and now we just need the red channel that I want to use for mixing. So if I take this one and put like a red color, this would be the cube, and this would be the edges. So let's do some kind of sci-fi cube here. I mean, who cares about materials, right? This is just a simple test that we're doing here. So I'm gonna set the metalness of these all the way to 1. So we have a metallic cube, and maybe I want this to be, no, maybe 0.2 was fine. All right. And then the edges, I want those to be metallic as well. But I want this to be sharper, and maybe tint them with some kind of red color. All right, so this is my beautiful cube. Okay, as simple as that. And this is how it looks from the camera. Maybe, I don't know, maybe we can actually get this a little bit rougher so it's more visible. It's not that reflective. And that looks good to me. Okay, cool. Fantastic. All right, so yeah, this is my render setup. I'm gonna set some shortcuts here. So this will be control 3. Then here, this would be control 1. And then we're gonna go to tasks. Let me switch back to build. So yeah, control, oh, I haven't set my shortcuts here, sorry. By the way, I made a mistake here. This would be my setup, and this would be my render. So I'm gonna call this one Geo1 render. I'm gonna set the render color, which is green, and here I will do an object merge, and I'm gonna point to the out. So basically I get this for rendering and this for creating the setup. Okay, so back in stage here, I should be pointing to my render geometry, which is that one. And by the way, to be a little bit more organized, let me add a null here. Call that one out, and back to stage. There you go. All right, so let me set the shortcuts again. Control 3. My setup here will be control 1. And now I'm gonna go to tasks. Here it is empty, we don't have anything. I'm gonna create a top network. And now we can go inside, and here we can build our top network. I'm gonna click on control 2. So now I have shortcuts for jumping between networks. So 1 is my setup, 2 is my top network, 3 is my stage lobs context. Okay, cool. So if we go back to tops, there is a node here called local scheduler that we don't care that much about this thing now. The only thing that I ever change here, and again, you can do with tops and PDGs, you can do very complex stuff, extremely complex stuff. And I mean, things that I don't even understand. But for everything that I do with tops and PDGs, the only thing that I ever have to change in my local scheduler is, if you go to job parameters, this single thing. Most of the stuff that I do, this is disabled. But if I'm doing very complex simulations, like smoke simulation, for example, or water simulation, well, I actually don't do water simulation. I'm not going to pretend that I do heavy effects work. But I do, from time to time, a lot of pyro and RBD. And if you're doing something complex, you require a lot of RAM in your computer, right? So these operations here in tops, they are happening all at the same time. But If you click on single, this one will run a job, and when the job is done, it will jump to the next job. So if you're using something that requires a lot of computer power, a lot of RAM especially, you cannot do like 20 Pyro simulations at the same time because you will run out of memory. So if that is the case, if you know that you're going to run out of memory because, one explosion is already complex enough, you cannot do 20 at the same time, then you would enable this. So it will do one explosion, and after that it will do the other one. It will handle everything automatically, but one by one. That's where you want to enable single. If you're doing something simple like we're doing here, like we're creating, let's say, 50 different boxes with different setups, for that, that's not going to consume a lot of RAM, so you don't need to enable this single option here. You can run all of those at the same time, and it will be just fine. Okay, cool. So now that we're here, we need to start thinking about what we want to do with this procedural cube. And what I want to do is the next. I want to change the size of my cube, and that will be a variation, or 10 different variations with 10 different sizes. And then I want to do another 1 or 2 or 3 or 1,000 variations where I split the cube. Here I'm split it in 5 different chunks, right? Maybe I want to do a variation where I split this in only 3 chunks, or maybe in 35 different chunks. What's going on? This one didn't want to work. Okay, let me do a regular explode view. For whatever reason, it's not updating. There you go. And let me do something like 0.2. All right, maybe I want to do another version where I do this, right? Where I do, where I split the cube in many other different chunks. Okay, let's go back to 5. Then we have the edge damage. And maybe I want to do another version or another 5 versions where I'm having different amount of damaging. And maybe I want to do another variation where, I don't know, we do like a second layer of damaging or whatever it might be. Okay. Let's go back to the cache version, which is this. So for that, again, if we go back to here, to tops, we can start introducing all those variations very quickly here. To do that, and by the way, those variations are commonly known in Visual Effects as wedging, right? So for that, we have a node called wedge. We actually have 2, like wedge and labs wedge, which are essentially the same, but this one, the labs one, is a little bit more simplified. I've never used labs tools here. There are a few labs nodes which I never used before. So I'm going to stick to the default ones. So this wedge, I'm going to call it wedge size. And this is going to control multiple variations of different sizes for my asset. Okay, cool. So here, wedge count means how many variations do you want to create? You want to create just 1, you want to create 2, or you want to create 200 different variations. That's up to you. Let's keep it simple for now. And again, you can introduce more complexity later, and we will. For now, I just want 2 different variations, 2 different sizes of this object. Cool. Then you have a seed here. And then you have the wedge attributes. So I'm going to click on plus, and I'm going to add an attribute name. This attribute name is not linked to anything yet. So the name is completely arbitrary. You can give it whatever name you want. It's not a global variable in Houdini. It's not an existing attribute that lives somewhere else. This is up to you to come up with whatever name. I'm just going to call it size. What type of attribute is this size attribute that we just created? Well, it can be float, it can be integer, it can be whatever you want. So of course, if I say float, I can go here from 0 to whatever. I can have decimals. If I go to integer, of course, I will go integer numbers. So I'm going to set that one to float. And the wedge type can be a range from 0 to whatever, or it can be a value, or it can be a value list, or it can be a bracket. Again, depend on what you want to do. In my case, I'm just going to set it to range. And what I want to do is I want to start with 1 and I want to end with 2. So I'm going to have two different sizes, 1 and 2. That's it. One for each of these wedges that we are establishing up here. If I say something like 1 and 10, still going to create only two wedges. One of them would have the value of 1 and the other one would have the value of 2. If I set this one to 10 and I go from 1 to 10, then I'm going to create 10 different variations. And the first variation would have a value of 1, the second a value of 2, the second a value of 3, and so on. Again, let's keep this simple. So only two wedges from 1 to 2. Okay, so this is created, but it's not really doing much. This is just the skeleton, right? This is just the basic recipe, but it's not linked to anything. We created an attribute, but we haven't linked it yet with anything. But we can check if this is working. So if I right click here and I click on dirty and cook this node, this is how you execute the node, or Shift V, it will cook it. And as you can see, it says here that we have nothing running and nothing waiting, and we have cooked two tasks or two jobs. And these little dots indicate that, like, this is the first job, this is the second job. If I middle click here, I can see some information here. So I can see that the wedge count is 2 because we had two wedges. We established that up here. The wedge index is 0. And if we take the other one, the wedge index would be 1. So each variation, we have an identifier that we can use later for other operations. And finally, at the bottom, you can see the value of that wedge is 1, and the value of the second wedge would be 2, which is what we established here. If, again, I set that one to 10, and I set that one to 10, and I dirty cook this node again, now we have 10 different jobs, right? So if I check this one, for example, I can see that this is the wedge index 5, and the value is 6. If I check the last one, would be a wedge index of 9, and the size is 10, and so on. The first one would be 0 and 1. Again, I'm going to go back to 2 and 2, dirty cook, and we go back to 1, 1, or 0, 1, better said, and 1, 2. Right, so now, how do we link this to whatever parameter we want to drive in our setup? Again, the attribute name is called size. So let me go to my setup. And here in my box, well, I'm not going to apply that to uniform scale because that wouldn't give us much difference because this is just a cube. But maybe I can link that to the y-axis, right? So let's do that. So we call the attribute size. So if we want to link that attribute to this parameter, we just need to type at, oops, this is in whatever language. I need to change that to my Swedish keyboard, right? So now I can do at size. There you go. And the actual number is 1 because we are looking at this thing, right? If we look at the other one, we can see that now the cube has been scaled to 2. If I set that one to 3, add that one to 3, and dirty cook this again, now I get 1, 2, and 3 different wedges, right? With 3 different variations. Okay, great. Let's go back to 2 and 2, because again, we want to keep it simple for now. All right, so we have linked a job to one parameter of the setup that we're building to create procedural assets. This is the essence, this is the basics of everything that I'm going to talk about today here when it comes to PDGs and tops. Okay, cool. But we want to run these through the whole setup, right? So we need to make sure that this cache is actually caching the wedges automatically without any human input, right? We want to control all of that automatically. How can we do that? Well, let's go back here. And what we can do now, we can add here something called fetch drop or drop fetch. Okay. And let's call this one drop fetch VGO. This is going to take care of caching our whole setup into a VGO geometry. Later, we will take a look at how to cache a USD file, for example, right? But for now, let's stick to VGO, which is, what works best with Houdini in terms of caching data, not only geometry, but data in general, or almost any type of data. Right, so this one requires, it's called a ROP fetch. So as you can imagine, it requires a ROP. And here you can see that it's looking for a ROP. Let's go back to the setup. But this is not really a ROP, right? This is a file cache. A ROP lives in other places, right? Like a ROP network. But the file cache inside actually has a ROP, which is this one. So we can just copy this. And by copy this, we're not copying the node, we're copying the location. So let's go back to tops. And here, let's paste that location there. There you go. And now it's linked to that ROP. Okay, that's all good. But if we go back to the setup, this one is basically just writing, let me remove that load from disk. So of course it's going to compute everything. Okay, this is what we have. This will cache only this file, right? So it will kind of overwrite, it will write the first wedge. And when it writes the second wedge, it will overwrite the existing file. So we don't want to do that. We want to write one independent file for each of the wedges. How can we do that? Well, so we are here, right? So what we can do is we want to create a folder structure for each of the wedges. So what we can type here is W, that stands for wedge. Then we need backticks, and for that you're gonna forgive me, but if you type backtick, this is the symbol. So basically I'm just gonna copy it from here because I'm using a Swedish keyboard and I actually don't know how to type that symbol. So you can just do that. So this is the symbol, the backtick. So you need two of them, and in between you type at wedge index. Okay, what is that wedge index? Remember that each of these will have a wedge index. In this case is 0, and in this case is 1. So by doing that, here, W backtick wedge index backtick, we will create automatically a wedge for each of these different cubes. Okay, cool. So let's see if that actually works. So here, dirty and cook this node, and you will get this message all the time, which basically says, do you want to save your file before cooking? Generally speaking, you want to do that, right? You really want to do that. This is the same as in a Visual Effects Studio when you send something to the render farm. Every time you send a job to the render farm, it will automatically be saved. And that is something smart to do, right? Because maybe 6 months later, you realize that you want to go back to a version that you did 6 months before. So you check Shotgun or ShotGrid or whatever it is called this week, and you see a nice render and you say, oh, I want to go back to that. So of course there is a file that has been automatically saved and associated with that render, so it's easy to find. Same thing with this. So you want to save, and this will start cooking, as you can see there. Okay, so as you can see, 2 jobs are running at the same time, right? Because we didn't specify anything else. So okay, this is done. So it was 4 jobs in total, right? 2 here and 2 there. So now, if you click there, oops, I think I forgot to set this one to read from files, right? Yep, read from file. There you go. That's what it was calculating again. But then we have this one, and then we have that one. There you go. So all of a sudden, you get 2 different variations of the same asset, where the only thing we change is the size, right? We only change the size here, but you know, you can start to feel how powerful this system is. Okay, if we check Houdini Geometry Live English, here we have our directory BGeo, and inside you can see that, well, this is what we wrote before, so you can ignore that. So here we have the wedge 0 and here the wedge 1. So inside of each of these, we would have our BGeo geometry cached out. Okay, so this is just working as expected. Okay, great. What else do we want to do in our tops setup? Well, we want to render all of these, right? We want to render all of these automatically. And we want to do, generally speaking, 2 types of rendering. One, and this only applies to simulations really, or animations, because if you're doing a simulation or animation, you might not want to render it because maybe the only thing you care about is timing, right? How fast is explosion or how strong is the wind. And to do that, you don't need to render. It would be a waste of resources. You want to do a play blast or a flipbook. It's called in Houdini, right? So to do that, you would do a flipbook here, right? You can also automate that here by rendering an OpenGL version, right? So you don't need to render a final render with Solaris, even though I'm going to show you how to do that also. But again, for simulations and animations or anything that doesn't really require visual fidelity, you might be fine with a flipbook. So to do that, we have something here called ROP OpenGL. In the same way that we have a Mantra ROP, if we want to render with Mantra, or we have a Karma ROP, if we want to render with Karma. These have all the settings, all the render settings here, right? This would be like a final render. I don't tend to use these. What I tend to do is I create my render setup in the way that we just did here, right? In LOPs, and then I can invoke this into tops, right? So this would be just some kind of overrides, if you will. But again, I don't tend to use this. What I tend to do is another ROP fetch, and then I will find my render operator here. So let's call this one ROP fetch OpenGL. Well, we created a setup for Karma, but we haven't created a setup for OpenGL. So we better do that first, right? So that's why I created this geometry render here. Well, not only for that, this is a common practice, but we can take advantage of this thing. Okay, so I'm gonna go to out, and I'm gonna create an OpenGL here. And in this one, I wanna use, my camera. I wanna force to render my GeoRender. There you go. And that's it. So basically it will render an OpenGL version of this thing that I have here on screen. Okay. I think that's everything that we need. Well, we need to specify the output, right? Because we want to render images, but we can go back here in a minute. Okay, so in this ROP fetch node, I'm gonna look for my out OpenGL. So I'm gonna use this thing now, right? In this one, I'm gonna go to where it's saying frames and batching, and I'm gonna click on all frames in one batch. So instead of distributing all of these in multiple computers, if you are using a render farm, or multiple processors, if you are rendering locally, I want, just one computer to take care of all this rendering. I don't want to distribute this in multiple machines. Why is that? Well, because this render is extremely fast, because it's just a Playblast, a Flipbook, an OpenGL render. So it might actually take longer if I need to distribute this in multiple machines, because those machines might be busy, and maybe this node is waiting for those machines to free up, so it can join the queue. So instead of doing that, I'm gonna say, well, if you find an available machine, just render everything that belongs to this node in that machine. Don't bother about using other computers. That's what I want to enable, these all frames in one batch. Okay, I think that's everything for that node. Yeah, that's everything that I need for that node. But now we need to actually, in the same way that we did here, remember that we had to go here and add, this syntaxes here to create a folder structure and a geometry for each wedge. I want to do the same for my OpenGL render. So I'm going to go to Out. I'm going to select this one, and here in the output image, I'm going to select a sequence of EXRs, but I want to change this. I want to render this in job, render. I'm going to create a folder here that I'm going to call Live English. There you go. And here, I'm going to say also wedge, backticks, and in between, add wedge index. So we will create a folder structure for each of the wedges. And now I think we're good. So let's go back to tops and dirty and cook this node. So while that renders, which should be extremely fast, let me go to my render directory, live English, and there you go. Here you have wedge 0, and here you have wedge 1. And by the way, we are just rendering a single frame, okay? As you can see in these folders, there is only one frame, which is the first frame, because this is not an animation, right? But if this was an animation, of course, we would have all the frames here. It will take longer to render, but we would have everything. Okay, let's see if that works. Let me go to render and play low disk files. And I'm going to go to job, render, live English, wedge 0. And if we load that, there you go. This is our cube, right? And if we load the other wedge, this is our second cube. Cool. So we can, as you can see here, create variations of a geometry in this case. But again, it could be a geometry, it could be a volume, it could be whatever. In this case, we're creating versions of an asset. We are caching them to disk, and then we are rendering an OpenGL version of them. Great. That's all good. That's all automatization happening here. Okay. Then, what if you actually want to render, a nice beauty image instead of an OpenGL? We created this setup here. Can we take advantage of this? Yes, we can. And you might think, let's add a rob fetch and point to my lob operator. And this will actually work, but there are some operations that we want to do down the line that won't work if using these for rendering lobs. And I guess it does make sense because, here it says rob path. It doesn't say lob path. So be careful. Don't use this one for lobs unless you stop here. If you say, no, this is all I want, I just want to render this, it will work. But again, this is not what we want to do. What I'm going to do here is add a null after the Karma render settings, because this is the node that takes care of Karma, and this is the node that is going to write the final images. We don't want to use this node for writing the final images. That's something we're going to do on tops. So we need this output basically. Okay, cool. So to do that, I'm going to do a ROP USD output. Okay, and then I'm going to do a USD render file. This one is not really needed unless you want to cache your objects. In this case, again, could be volumes or could be whatever. But unless you want to cache your data as USD, which I want to do because I work in a full USD pipeline. Okay, so I want to cache this as USD. Okay. So in this ROP USD node, lop path, and now it says lop path. It doesn't say ROP path, which is already a good sign, right? So I want to point to my stage out. This is the lop where I want to cache USD. I want to say in the style that I want a flattened stage, so it collapses everything into one USD layer. Because again, this is not the final thing that we will use in a scene assembly. This is just something that we're doing for us, for validating the work that we're doing. So, you know, keep it simple and flatten everything into stage. That's just fine. By the way, if you don't know what I'm talking about here, about what are the different stages of USD and whatnot, I have a very, very, very long series on my Patreon channel about USD. So you should watch that. Okay, and now where do we want to cache this USD data? Well, I want to cache it in job, geometry, live English, and now again I want to create directories for all the wedges that I'm going to create. So again, w backticks add wedge index, and this will write a USD file with, you know, these variables that I'm using here, which is heap name and $OS. Okay, great. Is there anything else that we need to do here? I don't think so. Okay, I don't think so. So let's run it and see if it works. So I'm gonna click on dirty and I cook this node and it will start running the two jobs. Let's go here. Let's go to geometry, live English, and now we should have, oops. My bad, I put it here. Okay, I meant to create an intermediate directory called USD. So I'm gonna get rid of that. And by the way, when you generate data, you can delete it directly here, or you can just click on delete this node outputs from disk. And when you do that, it will find the two USD files that we just wrote. So I can click on accept and it will delete them from disk. So if I go back here and I go inside, now these folders are empty. So let me get rid of this, because what I wanted to do is I wanted to create an intermediate directory here called USD. All right, let me dirt and cook this thing again, save. It's cooking, and now we should have a USD folder here soon. There you go, USD. And inside we have wedge 0, wedge 1, and inside we have our regular USD file. Okay, cool. Which is a USD, so it's not human readable. Otherwise you can render USDA, for example. Okay, but that's not what we want, because USD files are smaller. You can read them, but they are smaller on disk. Okay, great, but this is working. So finally, USD render. And for USD render, this cache mode is set as automatic, and that's fine. But I had issues in the past sometimes. So if I force this one to write files, then it fixes those issues. I'm not sure why is that happening, but just in case, I just set this one always to write files. Then the USD file that I want to use is upstream, which is basically what I cached with the ROP USD node. If you didn't have this one because you didn't want to write USD files, you can set this one to custom file path and just point to a USD layer. But in my case, I'm going to set it to upstream output file. Okay. Then here, you want to render a single frame or a frame range. In our case, it would be a single frame because this is not animated by any means. And the only thing we need to change now is the output. Where do we want to output this? I want to output that in job, render, live Spanish, USD. Okay. And let's take advantage again of the wedge index. So again, W backticks at wedge index. And this is when I render an EXR file for each of the wedges. So let me dirty and cook this node. Let's take a look in Houdini. Render. This will take a little bit longer because it's a render, even though we are using 3 samples, so it should be very fast. So if I go to live English, oh, my bad. Where am I? Houdini, render, live English. Oh, my bad. I wrote that in live Spanish. Fantastic. Okay. And by the way, I realized that I made a mistake before, so I'm going to get rid of that. And that is the OpenGL. Right? I was writing directly here in Houdini render live English. My bad, because I actually wanted to create an intermediate directory again. So this, I want it to be inside a directory that I call OpenGL. Okay, OpenGL. Okay. Back to tops. Right, so I'm gonna delete everything from here. So I'm gonna click on delete this node output file from disk. Yes, I want to delete everything. So now this one needs to be cooked, this one needs to be cooked, and this one needs to be cooked. But that's fine. So this is the OpenGL. This one was working fine. And this one, I want it to be not USD, sorry, Karma. There you go. So now I want to dirty and cook, dirty and cook this node, save, and it will start with this node, then it will jump to this one, and then it will jump to that one. So you don't have to go one by one, which is what we're doing just for clarity, okay, just to make sure that everything is very clear. But of course, none of these needs to be cooked, and then you can just go to the very last one and cook from here, and it will cook all of them in order. Okay. So yeah, now if we go to live English, yeah, now we have the OpenGL renders that you've seen before, and now we have the Karma renders. So let's see if that's actually worked. So I'm gonna go to template, load from disk, and I'm gonna go to render live English Karma. There you go, and this is the first wedge. Perfect, and this is the render that we've seen before from Karma. Of course, it's very noisy because we don't want to waste time. And if I load the wedge 1, this is the second version of the asset. Everything is working as expected, which is just great. Okay, cool. What else do we want? Well, now we want to create a contact sheet where, all the wedges, all the different variables, variations of these assets are presented to us in one single image. So I don't need to check one render and then check the other render and check the other render. And if I have 100 done 50 different variations. I don't want to check all of them individually. I want to just have a look and see all of them at the same time. So something that we need to add is text with information of what we are actually looking at. We want to know which wedge we're using. We want to know which size, which level of damage, which shader we're using, information. So for now, we only have information about we only have one wedge, which is size. So let's introduce that. So I'm going to create an overlay text. Connect this one here. And this overlay text, here in the overlay field, you can see overlay frame number. We actually want the frame number. So let me rename that and call it frame. Okay. And if we middle click here, we can see that we're in the frame 229. But if we scroll up and down, I have a keyframe here somewhere. I added a keyframe to something by mistake. Okay. Hopefully I didn't. What is that? Let me have a look. Okay. Well, I don't know. Hopefully we don't screw anything. Okay. So we want to know the frame. Cool. Because, later we're going to do some simulations and we want to know in which frame we are. But also we want to know the wedge index, right? Or variation, or you can call this whatever you want. I'm going to call it wedge index. And for that, I need backticks and point to that attribute, wedge index. So this will tell us which wedge corresponds to each image. Okay. And then I also want to know the size. So I'm going to type size and same thing, backticks at size, which is the name of the attribute that we established up here, right? Wedge index is this global attribute, wedge index. So that's what my bad. Sorry. I lost that. Wedge index. Wedge index. Okay. And size. Okay, cool. So now if I middle click, I can see that I'm in the wedge index 0 and size 1, frame 1. If I click on this one, now I'm in wedge index 1, which corresponds to size 2, frame 1. So this is all working. We just need to render it, but so far it seems to work. On this one, I'm gonna go to where is the thing? This is where is this thing? Here I want to activate again all frames in one batch for the reason that I explained before. I want one job to do all these frames because it's super fast to render. All right, and finally we need to set the output, right? So for the output, same thing as we've been doing so far. I want to render this in render live English, and let me create an intermediate directory here called overlays, and then again wedge backticks at wedge index. Great. Let's dirt and cook this node. So now we should have here in render, at some point we will get a folder, overlays with our wedges. Cool. Let's see how that looks. Live English overlays. Go. Yeah. And this works, right? So this tells us that we're looking at wedge index 0, size 1, frame 1, and if we load the other one, it will tell us that we're using the wedge index 1, which has a size of 2, and this is the first frame. Great. So again, if we're trying to do is variations, let's say 100 variations, and we want to pick only 5, the 5 that we like the most, then it will be very easy to find out in our system where those live, because we say, oh, we can track them down, right? We can say, oh, cool, it's wedge index 1, so let me go here and select wedge index 1, or this is 0, wedge index 1, and that's what I need. So I just need to take this one from my hard drive and put it into my scene assembly, for example. Cool. So yeah, this is all working, which is cool. Right. Okay, finally, again, we want to create a contact sheet with all that information. So we don't need to go checking renders individually. We just want to look at one single image, which could contain, all the frames of a simulation or whatever. In this case, it's a single frame, but one single image that provides all the information that we need in one single place. So for that, before doing anything, I'm going to add a partition by frame, which right now it doesn't really do much. Let me cook it. Save. It will group basically all the frames per wedge. This is what this thing is doing, right? This is creating this partitioning thing. It's only one bar here because there is only one frame. But if we would have, 20 frames and 20 edges, 20 frames and 20 wedges, we would get 20 different bars, and all the frames would be, again, grouped per wedge. So there is really nothing you need to do with this now. This is just an organization thing. So I'm going to keep it there. And now I'm going to add an image magic, and this will create a montage. Again, a contact sheet. Make sure that you go online and download Image Magic. This needs to be installed. So you go to downloads and download it for your OS, in my case, Windows, install it, and it will work. You would have to restart Houdini because it will need to add the environment variables to your system, but then it will work just fine. Okay, but yeah, you need to restart Houdini. In this Image Magic, we have a couple of things that we need to do. The input is upstream, so basically everything that has been cooked before. The operation, it has multiple operations. I tend to use montage, which is again a contact sheet using the full resolution of the images. Cool. And I think this is everything that we need. We just need to specify where we want to save this montage. And for this one, it comes already with this variable at PDG index, okay, that it will be given by the upstream. We don't need to specify wedges, right? Because here we don't want to render individual edges. We just want to combine the existing ones. But yeah, I want to render this in job. Not in images, but in render live English, and I want to call this montage. Okay, cool, great. Dirty and cook this node. That's it. So now, if I go to render and play low disk files, and I go to job, render live English montage. Here I have my contact sheet. So when I load that, there you go. Now you get all your variations here, basically. Okay. So yeah, we only have 2 different variations. This rendered with. This looks a little bit dark to me. Let me check if. Okay, yeah, it's a little bit weird. Anyway, I think it's baked in the lookup table because this doesn't look this dark in Solaris, does it? Let me check one thing. Karma. Yeah, it's definitely brighter. I think this is baked in. Let me check. No, this doesn't have options for baking. Oh, it's because it's writing a PNG, I think. There you go. So I'm gonna delete this output and cook it again. There you go. Now it's working. Of course, PNG doesn't support embedding ACES. Okay, so yeah, now this looks fine. Cool. Yeah, but the important thing is like we created a contact sheet that contains all the different variations that we created of this asset with the information that we need, right? The wedge index, the size, and the frame. So as you can see, you can easily identify which one is which. And yeah, this is basically the bare bones, right? The skeleton of this system. As you can see, it's extremely powerful. So we can make it a little bit more complicated now with this asset. And then we can also take a look at how to use this with something more complex like some kind of simulation, okay? But hopefully you are understanding how important this thing is. And again, if instead of two different variations, we would be creating 100. Again, by the end of the day, you go here, click on dirty and cook this node. You come back next day, and in the morning, you would have 100 different variations. Then you would have 500 different geometries cached as PGO, 100 different geometries and lookdev and everything published as USD files. And then you would have 100 different renders of potentially a turntable of each of the assets ready for you. So you can basically analyze your work and pick and choose which ones are working, which ones are not, or maybe all of them are working and you just want to use them in your scene assembly. Okay, this is the goal. And finally, you can also speed a video out of this because these are just a sequence of images. You can combine all of that into, if you use an FFmpeg encode video. This is something that I don't really use because I never work with videos, right? I always work with a sequence of images. But you could do that. You could set this one to, and of course this wouldn't handle like color correction or anything like that. But if you go here to job, render, live English, and then we do something like video and render this. Well, this is complaining, and the reason that it's complaining is because here I'm using EXRs, and it cannot use an EXR. It cannot create a video out of EXR. So if this one was a PNG, then it will do it. All right, I believe so. So let me delete this stuff here. And dirt and cook this node. Okay, it complained. Why? Oh, yeah, I know why. Okay, so maybe it worked actually with EXRs. Let me check. Delete all the stuff. The reason that it's complaining is because it needs to create this frame list file first, which is just a text file, and it needs to live exactly in the same location. So I'm going to copy that and I'm going to paste it there. Okay, and now if this and this are in the same location, this should work. And if it doesn't work now, it might be because of the, oh, my Houdini crashed. Okay. Let me launch Houdini again. Yeah, it might not like the EXR input. But yeah, I think FFmpeg can handle EXRs, but it wouldn't know what to do with the color space. So it's not gonna look good anyway. Yeah, let's try again. Okay, so let's go here. Let's go to video, and here we have a video. And if we play that, yeah, I mean, of course, it's just one frame, so it's just looping over one frame. There is nothing really to see here. Actually, it handled the color space very well. So yeah, I mean, if this was like a turntable, we would see like like a turntable happening here, but yeah, we can do this later with the simulations. You can actually see it better. Okay, cool. So this is the first part of today's video. Hopefully you think this is interesting, because again, it's extremely powerful and it will save you a lot of time and headaches and tracking down files and doing multiple render setups for something that should be or can be automatic or automated. So yeah, this is the thing. Well, actually, sorry, I'm lying. This is not the first part of the video. I'm still want to show you a bunch of things with this, which will take me 10 minutes more. Okay, and after that, yes, we will conclude the first part of the video and we will move to the next part. Okay, so as I was saying, let's make this a little bit more complicated, because right now it's only two variations and the only thing that we're wedging is the size of this thing. So let's make something a little bit more complicated, which is basically building up on what we have. So there is nothing new, I believe, here. Okay. So back to tops. We have this wedge size. And by the way, now that we're here, I'm basically gonna go all the way down and click on delete this node output files from disk. Accept, and actually, you can do that anywhere, and it will get rid of all the dependencies, right? Okay, so yeah, we have this wedge. Again, if we cook this one, it gives us only two variations. Okay, and we're wedging the size. What else can we wedge here? What else can we get a variation for here? Well, for example, the breakups, right? The pieces that we're getting from the attribute, from the RGB fracture, right? So if we go here, we're getting this amount of fractures given by this scatter. So let's control that with a wedge. I'm going to create another wedge, and this one, I'm going to call it maybe wedge pieces or wedge breakups or wedge scatter. Why not? How many variations do we want of this breakup? Up to you again. Let's do 3. Okay. Let's create an attribute. Let's call it whatever you want. I'm going to call it scatter. It's integer, because I want to go, integer numbers. And what type of wedge? Maybe value list. Before we use a range, now we're going to use a value list. We have 3 wedges, so I need 3 values. And maybe I want a value of 3. Maybe I want a value of, let's say, 6 and a value of 10. Let me dirt and cook this node. And at this point, we're going to have 6 different variations, because we're going to have 1, 2, 3 variations with this size and another 1, 2, 3 variations from this other size. Okay, cool. Great. So the only thing we need to do now is hook this scatter attribute here. So let's go to scatter, and here we do add scatter. Okay. So now we get, it's a little bit hard to see, but now we have like 1, 2, 3 points. And if we enable that one, then we would have 10 points, right? Cool. So this is just working fine. What else can we wedge? What about the amount of damage, right? Which we are controlling with this one. Okay, so let's create some more variations. Let's add a wedge pipe it here, and let's do wedge damage. Okay, let's do, yeah, let's do 3 variations. Oops, sorry, just one. Let's call it damage. Let's say this is integer, and let's do maybe we can do random as well, but yeah, maybe I want to do like a bracket, let's say, from 0. Oops, this should be float. 0.3 to, let's say, 3, perhaps. Okay. Oops. All right. Because we use a no, sorry, 3 is the default that we're using here. So let's do from 3 to, let's say, 9. So this will give us like 3 variations, right? So let's cook these. And yeah, as you can see, this one gives us a damage of, oh, -6. Why is that? Oh, sorry, not, I wanted to use a value list. Value list. Okay, so let's do 3, 6, and 10, for example, and we can do random, so it will randomize that. So now we get something like a damage of 3, a damage of 3, a damage of 10, a damage of 10, 3, 3, 10. Aren't we getting any 6? Yeah, here we're getting some 6s. Another 6. Yeah, so we're getting random values from 3 to 10. Okay, that's cool. All right, let's hook this up. So let's go here and let's do a damage. That's great. And finally, we want to do, let's say, a shader variation. Why not? So let's go here. Of course, we don't see anything. And the reason why is because we haven't cooked anything yet, because this wasn't hooked before, right? So let me delete everything. Okay, cool. I'm not going to cook it just yet. Let's wait until the end. I want to create a material variation, for example. So I'm going to go to stage. I'm going to duplicate this box material. Let me call it box 1. And here, let me just change this. So this one, I'm going to make it golden kind of color, something like that. And this, I'm going to put it like black. Okay, cool. So now I want to control that by a switch. So this one goes here. This one goes here, and in here I'm going to use that other material and pipe it here, and I will control that with a wedge also that I'm going to call material. So, you know, while being here, let me point to material, even though we haven't created that yet. So let me add another wedge that I'm going to call wedge material. And here I want to use 2 wedges because I have only 2 materials. Gonna call it material, and it will be 0 and 1, and that will be the 0 input of my switch and the 1 input of my switch. Okay, so we are good. Before cooking all of this, I want to add that information to the overlays. So I'm going to go to the overlay here, and let's add that information. So basically we said scatter. So maybe let's do amount of pieces. And let me just copy this. And this one we called it scatter, right? Scatter. And this one we called it damage. And this one material. So let's add all that information also. So that would be amount of damage, and finally it was material type, material. Okay, we're good. So now we can just come here and dirty and cook this node, and this will create tons of variations. You can see here that we are creating, you know, incrementally we're adding more variations. So this one will get like well, it's not cooked yet, but here we will get like 16 different variations of geometry, and then those 16s will have 2 materials each, so that will be like 24 different variations. So you know, is cooking all of these simultaneously. It will take a few minutes, I guess, because we need to write all the BGOs, we need to render all the OpenGLs that we are actually don't care for this asset. We're going to write all the USC layers, and then we're going to render that. So let me pause the video, and in, I don't know, 5 to 10 minutes, I'll come back with the results. Okay, this is done. We don't see anything in the screen, right? Which is expected because we don't have any of these activated. But you know, if we click on any of these, we will start seeing all the different variations, right? So different levels of damage, different scales with different parts, with different levels of damage and whatnot. Everything is here. But we want to take a look at our beautiful contact sheet the next morning and pick and choose, or see if, you know, what we've done actually is what we expected. So let's go to render and play load disks from file, load file from disks. I go to job render, live English, montage, and then we would have, you know, this is a 189 image, 189 megabytes image, because of course it's a very large image. So load that, there you go. And these are all our variations. So you can see, like, you know, different materials, which is only 2 materials in that sense. And then different amount of pieces and different amount of damage. So if we zoom in one of them, like here, for example, we see that this is wedge index 20 with a size of 2. Okay, the amount of pieces we have is 3, and the amount of damage that we have is 6, and the material type is 0, which is the first material that we're using, and this is the first frame. And I don't know, if we go here, you can see that this is wedge index 34 with a size of 2 and 10 pieces. We did it for the breakup, and 10 is the amount of damage, and it's using the material 0. This one is using the material 1, and so on. So this is a very nice way of presenting your work and create variations for yourself or for your production supervisor or whoever might need this kind of work. And again, these are just steel frames, but if we had a turntable, you know, we would just hit play and we would get this. Okay, cool. Yeah, and again, this can go to Nuke, this can go straight into ShotGrid or anywhere else. This is just, it will save you a lot of time, right? Imagine if you have to do all of this manually. Great. Okay, so yes, now this is the end of the first part of the video. I will jump into the second part of the video soon. Well, the video that we generated here, it was actually created, but I don't think that will work because I don't think it will. Will it work? Oh yeah, actually it does. Yeah, I was thinking like maybe it was huge, but of course this gets gets into the MP4, so the actual compression is quite big. So as you can see, this is just like 3.3 megabytes. But yeah, it is working. I don't think it's very useful to have a output video, at least in the visual effects context where we only work with a sequence of images, but you have it. Okay, you have it. Cool. Yeah, first part of the video. Okay, so now that we understand how TOPS work, at least the basics of it, let's just take a look at something that I made for this video, which is also very simple, but I just want to give you like a real world example of how I use TOPS. So, I mean, you've seen these already, I guess. But here I have like 3 versions of this animation, which is basically, you know, like a sphere colliding with this undulated ground. And then we have some hair simulation on top of it. And I just wanted to make something simple for this video, for this exercise. So it's, you know, this is not any particular job or anything. But I just wanted to create something that looked quite different. That's why these 3 hair simulations look very different. Not only in terms of simulation, they are actually the same. I didn't do any variations when it comes to simulation. It was all about look. But yeah, some hair is longer, some hair is shorter. This one here, as you can see, it doesn't grow everywhere. It has some kind of baldness to it. This one here doesn't have any clumping. This one has clumping. This one has a lot of clumping, and also the shaders are different and whatnot. So TOPS are very useful for something like this, because if I don't know what my goal is, what my end result is, TOPS is great, right? Because instead of sitting in front of the computer for one day, tweaking the hair parameters, the hair settings, the shaders, you know, tweaking something for a couple of hours, and then I like it, I end up with something like this, right? Here on the top left, I end up with something like this, and I say, yeah, this is cool. I spent 2 hours working on that. And then I say, but I want to create something also a little bit different. So I would save that file. I would jump into a new file and I would start tweaking until I get something like this one here in the bottom, right? And again, it would take me a couple of hours to get this look. And then I say, cool, I have 2 looks that I like. Let me try to find a new look. And then I spend another 2 hours and I end up with this look up here. That's all good. You spend 1 day working on things, fine. And of course, if you have a goal, if you have a target, if you know how things are supposed to look, then you just work to get that and that's it, right? But if you don't know, if you're just exploring like different looks, instead of spending a day working on these 3, what I can do is I can set up a TOPS network and I can say, well, give me 400 different variations. And that's going to take maybe 2 days of computer power, right? Because you need to do all the 400 simulations, you need to do all the 400 caches, you need to do the OpenGL renders, you need to do the USD renders, and whatever you need. It might take a couple of days, like your computer working full time. Fine. But that's just computer time, right? In the meantime, you can keep working on your project, keep doing all the things, all the tasks. And 2 days later, you have 400 versions, and you can choose 3 or 10 or whatever you like. And, that was all human free time, basically time that you spent working on something else. You didn't have to keep tweaking parameters until you get something. So when it comes to simulation, I use TOPS a lot. Okay. So let's take a look at this setup. I can walk you through it. It's very simple. It's basically repeating what we already know. So here you can see that I have a simulation, just one of them, right? This is kind of like a base simulation that I have. And I have my setup here. I can walk you through that in case you want to tweak it or you want to do your own tests or whatever, but it's extremely simple. And then what I have here is basically the things that I'm rendering. So I have a ground, which is basically a grid with some kind of noise. So I create these ondulations just to get something a little bit more interesting. And then I have this ball, and this ball basically is a balloon simulation. It's a cloud simulation. It has some wind, as you can see, so it gets pushed, and then it contacts with the ground. And based on the undulations of this ground is doing these things. And as you can see, it's deforming a lot. And that is on purpose, right? I wanted to deform this sphere a lot because I'm attaching hair to these things. So when it gets squished, we're gonna get also different volumes in the hair, which is something that I wanted to get. I wanted to get something interesting, not just a sphere, but a sphere that is deforming quite a lot. So you get something of this nature, right? Which looks, quite nice for this exercise. It's just an exercise, but it looks cool. So yeah, this is the material that we're working with. So let me take a look at the setup here for you, because it's very simple. We're not gonna make this from scratch because it will take us like, I don't know, half an hour or whatever. But basically, I have two things here. I have this sphere. Let me hide all this stuff. So we have a sphere, and this is the sphere that we are deforming. And then we have this ground that we're using for collisions. Okay, cool. So the sphere, basically, it's basically a vellum cloth and a vellum strut constraint that deforms that sphere, right? Of course, it's here. So you get that simulation. You can tweak it as you want. You can make it more bendy or more stretchy or more stiff or whatever you want to do with that. That is just a regular vellum, okay? And then what I'm doing is basically scattering some points in that sphere. In this case, I'm scattering like 2,000 points, as you can see here, right? 2,000 points, cool. And I'm with a copy to points, I'm basically copying this line, right? That line over here, and this will be the guide for my grooming, basically, and I will use this for clamping as well. That's pretty much it. And then I'm resampling that to get more points, so I can curl these lines and I can get like soft simulations and whatnot. And I'm using that to create a vellum hair constraint. Okay. Then what you need to do, you need to attach this to the sphere, and to do that, the only thing you need to do is pipe everything into a vellum constraint glue in this case. So basically, you take the vellum hair constraint and the vellum strut constraint that I'm using for the sphere, and then you merge the inputs. So I'm merging here the geometries and here the constraints, and then you pipe that into a vellum constraint, and that's it, right? Then you run everything through Vellum Solver, and I'm using the ground as collision geometry, and that's it. And then inside, the only thing that I have is a pop wind, which is very strong with a wind velocity of 5 in the x-axis. And then I have an amplitude of 3, so it pushes it quite a lot. And this simulates quite fast. It's not, and as you can see, I haven't changed anything in the Vellum Solver. I'm using the default parameters. So I'm using like a very low resolution, like 1 sub-steps and 100 constraint iterations. So if we play this, it should play pretty fast, as you can see there, right? So yeah, I mean, even if I do like 400 different simulations, again, it will take a day or something, right, to do absolutely everything that I need for this simulation. So it's not, it's not heavy or anything. It's just that. Okay. So of course you can create wedging for the simulation, right? You can basically wedge the Vellum constraint settings, like the stretch and the plasticity and whatnot, and you can go to the Vellum hair, and you can also play with the stretch and with the bending, and you can also play with the Vellum solver wedging if you wanted to. In this case, I did not want to do that. The only thing that I wanted to change was the look of the hair, but the simulation is the same. So if you take a look at these videos again, they all share the same simulation. The only thing that is different between those three renders is the way that the hair looks, right? So here we have like a very dense hair with a lot of clumping, and it has this kind of red hair shader. This one here doesn't have any clumping. It's just like a lot of hair, a lot of curling, and it's longer than here, right? And then in this one, I get kind of like something in between where I'm using some boldness, right? So you can see the sphere because I'm using like a noise to control the density of the hair, and I'm using a lot of clumping, a little bit of clumping, a lot of clumping, a little bit of curling, and the hair length is shorter than the other two. So I get something like, I don't know, like a zombie hair or something that is damaged, right? That's basically the difference between those. So how did I end up with those? Well, just by creating a lot of wedges, right? So after that, after I have the simulation in place, then what I'm doing is just the hair system, right? So what I do is I just take the animated lines here with the balloon simulation, right? And then I create like a rest pose here. So that is just a rest pose. So basically I'm using a time shift for the first frame, and then I'm creating a rest attribute. And I'm doing the same with the ball, right? So I have the simulated ball, the static ball or the rest frame, and then I'm using a guide skin attribute lookup. So by doing that, I'm basically skinning the lines to the geometry of the sphere. And from there, I just create a hair generation, and this is just regular grooming tools. So I create hair out of those curves, and then I also have clumping to create some clumping. So in the hair generation, we want to tweak parameters like the amount of hairs that we're using, right? So we can use very little hairs, or we can use more hairs. Then we can also tweak the thickness of the hair and the profile of that thickness. I think that's the only couple of things that I'm changing here. Yeah, maybe you can also tweak the influence radius, the decay. I mean, you can, this is just grooming tools. And then I have the clumping, the same thing, right? For the clumping, I'm using things like the blending, the clump size. I get bigger or smaller clumps, the crossover rate. So, some hairs move outside of the clumping. Same with the straight rate, for example, right? So I get a little bit more variation. And then I also start adding like fractal clumping, so I get more variations in my clumping, and I get also some curling, so we can get, something that is more straight or something that is very curly, right? So those are basically all the wedges that I'm doing, right? So to control that, I'm using a top network, and I'm using exactly the same setup that I showed you before in the previous exercise. The difference is that now I just created an HDA, a simple, extremely simple HDA that is called Top Basics Template. So this is just something that I create, and if I go inside, there is a top network, and if I go inside, I have my structure ready to be used. So I have like 3 wedges, but we can add as many as we want. We have the ROP Fetch VGeo that is going to take care of caching the geometry in the way that I showed you before. We have the ROP Fetch OpenGL that is going to take the ROP path for our OpenGL rendering, In this case, it makes sense to do OpenGL because we can check the simulations, right, before rendering them, if that's something that you want to do. Otherwise, you can continue by, using the ROP USD, and this is going to write the USD caches, the USD render, which is going to use the LOPs to render this thing, the overlay text, partition by frame, ImageMagick, and FF and encode video that is going to output a video. That's pretty much it. And then if I go to Solaris LookDev, I also have here my hair, ball, and ground ready to be rendered, right? I have 3 materials that I want to test with 3 different hair colors, which is basic, or hair looks, which is these 3 looks that I have here in terms of shading. And then I just have a switch here that controls assignment of those, shaders, so you create variations in the way that I have here. I mean, this is basically what I showed you before, but with a simulation or with a more complex scenario. That's it. Then here you of course would need a null that is going to be fed into the TOPS network, and that's pretty much it. Okay, so yeah, so basically how would you start working on this, right? Well, let me go back to build here. You would do the same thing that I showed you before. You need to spend a little bit more time on the setup, of course, because for example, one of the first things that I want to do here is, by the way, I created this global attribute here that is called your task name. So here you would type whatever, like hairball or something. And then the nodes that, for example, the ROP USD, it's already set to write the right things, with the wedge index and everything. So you don't have to type that manually. And as you can see here, I'm using that global variable called task name. So it will create the intermediate directories for you based on your task name. So if I call this one hair ball, for example, right? Then this one will write automatically the hairball directory. And same for the USD, same for the USD render, it's just in the same variable, same for the overlays, same for the ImageMagick, and same for the final video. So you don't have to worry about, typing all those variables and everything in there. Everything is taken care of automatically. So you can do that if you wanted to. So yeah, so I start with this wedge that we can just rename to wedge scatter, for example. I can say here that we want 2 different wedges or 3 different wedges, right? And then we can just add an attribute called scatter, and I want this one to be an integer, and I want to go from, let's say, from 1,000 to 3,000 different points, right? So then I can just go to my scatter here, right? And I can just use here scatter, right? Display that. And if we go back to TOPS and cook this node, dirty and cook this node, then we have a version with, a version with 1,000 lines. Then we have a version with 2,000 lines and a version with 3,000 lines. Okay, we can change that to from range to bracket, something between 1,000 and 3,000. Dirty and cook this node, and dirty and cook this node, and we might get something different, right? So that's all up to you. You want to use it in whatever way you want. So yeah, I'm gonna do something like that. Cool. By the way, you can automate this actually if you want it with a little bit of scripting, but of course, every time you change some wedging, you need to go to your overlay text and change that here. So of course I want to call this one scatter, and I want to call this one whatever, scatter, or number of lines, or amount of lines, or whatever you want to call it, right? Again, you can automate that if you wanted to with a little bit of wrangling, but I haven't implemented yet. I haven't implemented that yet into my HDA, but feel free to do it if you want to. Cool. And then, I would keep wedging these things. So for example, another thing that I want to wedge is the length, right? So I'm going to set that one to maybe, 3 wedges, and I want to wedge the length. Maybe this one can be float, and maybe I want to do something from 1 to 3.5, for example, right? So now I can just go here and go to my line, and I want to set the length to that attribute length. Okay. Then we go back here, we dirty and cook this node, and all of a sudden we get a length of 1, a length of 2.25, something between 1 and 3.5, right? And here we would get another one for 3.5, and that is wedging the first wedge, which is the 1,000 lines. But of course, if we go here, we're wedging now this value over the 2,000s, right? And finally over the 3,000 lines. So as you can see, we are very quickly introducing a lot of variation here. So we have so far 9 wedges, and we barely started creating wedges, right? For example, then I can wedge the density of my hair generation, right? So if I go here, now I can go to my hair generation. And again, in my particular case, in these things that I created here, I'm not wedging any of the simulation, but you could do that if you wanted to. That's probably going to end up with many, many, many wedges. So very easily, you're going to end up today with 500 different wedges, which might be overkilling. I mean, that's up to you. Again, this is computer time. So, it will take a couple of days to do everything. If you can afford that because you have all the tasks to do and you have another computer or you have a render farm, that might be totally okay. But 500 wedges might be overkilling for something like this, right? So maybe you want to do wedges for in 2 different ways, right? Maybe you want to do wedges just for simulation, and you pick from 50 different simulations and you're happy with 10, then you take those 10 and you wedge the hair generation or the look of the hair, right? So that will be 2 different branches. So you don't end up with 500 different, but maybe you end up with 150 or something, right? Or 20 or whatever you might need. But yeah, I'm not wedging any of the simulation. What I'm wedging, again, is the hair generation. So in the hair generation, we have the density here, right? So let's set this one to density. Let's go back to tops, and let's call this one wedge density. Let's add maybe like 5 different wedges. Let's call it density. We can just float, and we can do something between 1,000 and 10,000 values for the density. So now if we dirty and cook this node, there you go. You see that right now, we already have quite a huge difference here when it comes to wedging, right? So yeah, so far we have 45 different wedges, okay? Do we need more wedging? Okay, cool. Just add another wedge. And maybe what we can wedge now here is something related with clamping. So let's call this one clamp, for example, blend. Clamp blend, okay. And maybe we want to create 3 different wedges for that, right? So let's call this one clamp blend, and maybe same thing. Maybe instead of now we want to use instead of range, we want to use a value list now, for example. So let's give it 3 options here, and the 3 options that I want to give it, it's for example 0, 0.5, and 1. Okay, so now we can go here. We can go to oops, sorry, not there, but here we can go to the clamping, And this blend we want to control with the clamp blend. Okay. So let's cook this guy, dirt and cook this guy. And look at that, right? Now we're getting like completely different clamping, which is, causing some issues sometimes, like here, for example. That is just because I have a lot of curling, right? So this is obviously another parameter that we actually want to wedge. And the fractal clamping is also another parameter that we want to edge. So we create some variations that are very messy, like these, and other variations that are very straight, like that. So we can wedge all of that. But again, be cautious here, right? Because so far we have 135 wedges. So yeah, if we add another 10 wedges, we're going to end up with 700 or whatever different variations. And of course, that will take a long time. Again, maybe for this whole thing, caching the VGLs, caching the USD, rendering the OpenGLs, rendering the USD, it might take maybe like a couple of days in my personal computer here at home. So again, maybe it's Friday night, you send this to render, and then, on Sunday you have everything ready and you can browse those 700 different variations, and then you pick 10 that you like and you go with that. Okay. So let me actually open this scene, because I didn't go that crazy, or actually I did at first, but I just realized it was just too much stuff. So I end up doing only like 18 variations, I think. So I did some wedging for the scatter, some wedging for the length, some wedging for the resample of the curves, so I get less or more points, some wedge for the density, some wedge for the thickness, the clamp blending, the clamp size, the clamp stray rate, the clamp iterations, the clamp curling, and that was it. So I ended up with only 18 different resolutions, because I didn't add too many options to the wedging, maybe only one or maybe two. Yeah, that's pretty much it. Then you, of course, need to cache everything as VGO. In this case, we're using a frame range, because this is a simulation, so we have like you can see that I have everything cached into disk. So yeah, something like this looks completely different than that, and completely different than that, and than that. So we have a good variety, good range of things here already, even though it's only 18 different wedges. I cache everything to VGO, and these are using the wedging for caching, as I showed you before, so you know how to do all of these. And then I wrote OpenGL versions of everything. So basically, if I go to render and play load disk from file, did I click on it? Okay, no. Yeah, I had. Sorry. So now if I go to render, hairball, and all these intermediate directories are automatically created for me, so I don't need to worry about that. Everything goes to the right folder. So if I go to OpenGLs, I have all the wedging here that I can check individually, right? So we can see how things look like. So we can go one by one and check how they look. This one looks completely different. More clamping, more curliness to it, longer hair, and I don't know. If we take a look at something else, also looks different, right? So yeah, 18 different variations here. Cool. Then, we write everything as USD. We render everything with Karma. So again, if we go here and we check the Karma renders, same thing. We can see how things look like. They should have ASUS transformation. There you go. And as you can see, I'm very using low quality settings, because these are just previews. These are not the final renders. They could be if you wanted to, but of course, then it will take more than 2 days to do everything. If I'm rendering this, let's say, with good settings, some 4K resolution, right? Then it will take whatever, like a week in a personal computer. But yeah, it's very, very convenient, and it's very easy to see how things look like, and everything looks different, right? So that's all good. Yeah, and then we're doing, the compositing and everything. So basically, if you go to here and you go to Montage OpenGL, then you will see the 18 different variations in OpenGL. This is not gonna play real time because this is a huge image. So what I end up doing is, I just take this into Nuke, basically, and I just output kind of like, like a smaller resolution thing, so I can see everything like in 4K or HD or whatever you want, 2K. And then I do the same with Karma, of course, and at the end of the day, I say, well, I like this, and that, and I end up with 3 different versions here, right? That's basically what I've done. Yeah, I think at the end I did like maybe 170 different variations. That's what I ended up with. And that is basically the process, right? So again, in the first exercise, I showed you how to use TOPS for creating procedural assets. So, static assets, basically procedural assets. They could be buildings, they could be whatever. We just use something extremely simple, but hopefully you got the idea. And in this second exercise or this second example, even though we didn't do everything from scratch because it's basically repeating the same thing, but hopefully you get the idea how to use this with simulations and with different looks, in this case with grooming. But again, I use tops and wedging and PDGs with pretty much everything, right? Especially when I don't have a very clear goal, when I don't know exactly what I want to achieve, right? If I just need to try things because that's my task is to do some exploration of looks, then I use wedging and tops in general a lot, okay? So yeah, for simulations of any kind, like grooming or RBD simulations or smoke simulation, clouds, and environmental volumetrics, I use PDGs a lot. I use PDGs a lot when I'm creating procedural assets. I use PDGs a lot when I'm developing terrains, like grounds and mountains and cliffs and that kind of thing. I use it a lot. I mean a lot. So hopefully you can see how useful tops are. There are many other things you can do with tops, but again, to be honest, what I show you is what I use 90% of the time. And hopefully you can incorporate these workflows somehow into your pipeline, right? What I would suggest to you is force yourself to use tops in the next task that you're facing, right? So let's say you're developing an environment. Let's say use tops for one of the tasks. Even if it's a small task, like creating rocks that you want to scatter, or maybe to create different variations of the scattering system that you have for scattering plants or scattering rocks or scattering trees. Just use tops to create 4 different variations, and you will see how powerful this workflow is. And honestly, it's something that I cannot live without these days. I use it again for pretty much everything that I do. Also consider that in my current job, I'm doing a lot of exploration, right? Because I don't have a client. I am the client in a way. So it's up to me to come up with creative solutions. So for that, tops is great because, again, if I want to create a forest in 10 different ways, I just create a basic setup, and then I set a computer on the side and I click render, and 2 days later I have 10 different forests to choose from, or to evaluate and see what I like from one and what I don't like from the other. So yeah, hopefully you found this video interesting. Hopefully you learn a little bit about tops, and hopefully you can incorporate that into your workflow. So this is the video for today. I don't think it was too long, right? I think it was around 2 hours, which is the goal that I always have, even though sometimes I go up to 3 or 4 hours. But yeah, if you have any questions or suggestions or anything, please let me know. And again, I always ask you guys, like, if you have any ideas or any suggestions for future tutorials, please let me know. This tops tutorial is actually something that a couple of people asked me to do. That's what I did it. So, I tend to hear what you guys have to say, even though I have my, my list of tutorials that I want to go through. But yeah, any suggestions are very welcome. And again, thank you very much for supporting my Patreon. I really appreciate that. And I will see you in the next video. Bye bye.